All right, welcome everybody. In this video, I'm going to show you how to model a cantilever beam in ANSYS and do an FEA analysis on it. So the first step, we're going to go to our toolbox and grab the static structural and drag it over to this green dash box. Then we're going to right-click on Geometry, and I like to use Design Modeler, and click Open Geometry. All right, the next thing we're going to do is we're going to model the beam. So the way that I've done my hand calcs is I've modeled the beam on the cross section of the beam on the YZ plane. So we're going to click on the YZ plane and orientate ourselves normal to the view by clicking this arrow down here. The next thing I'm going to do is I work in US units, so I'm going to change the US units to, or the units to US units. Then we're going to come over here and click sketching, and we're just going to draw a rectangle. So I'm going to draw a rectangle approximately about the origin, and then we're going to dimension it. First, I'm going to constrain it so that each of the sides have equal length. So I'm going to click the first side and then the second side. And then I'm going to dimension it so that the origin of the global coordinate system aligns with the center of the rectangle. So I'm going to go and click on horizontal. And now in this coordinate system, horizontal is going to appear to be vertical here. So I'm going to click this point and then the center point of the origin. There we go. And I'm going to set that dimension to 1 inch because I want to do a 2 by 2 rectangle. Then I'm going to click the vertical dimension, and if I can dimension it here. There we go. Set that equal to 1 inch. And then click general and set our sides equal to 1 inch. I'm going to do one more vertical dimension just to center it. There we go. And now I'm going to extrude it. So we'll go back to modeling, go to create, extrude, click on the sketch as our geometry. I'm going to leave this to 12 inches and I'll have add material and click extrude. And we're done. That's our geometry for the model. All right, so we're going to go back to our main menu. Right click on model and then right click and click edit. All right, and the first step I'm going to do is I'm going to set my units. So I'm going to go over here and click the Home tab and click Units and make sure that we're working in U.S. customary units because that's how I've done the hand calcs for that in U.S. units. Next, I'm going to make sure that I set a material. So I'm going to go under this drop down in geometry. And then you can click on the solid that your geometry is represented by. And down here, you'll see material assignment. And I'm happy with that just being steel. So we'll make sure that's set. And then you can also see in this folder here in this tab, if you add other materials to the analysis, you can see them here. And if you want to add a material on the fly, you can do that by right-clicking. So we've got our global coordinate system set at all the way at the left end of the beam in the center of the beam. And the next step we're going to do is we're going to mesh the model. So first thing I'm going to do is I'm going to change the element order from program controlled to quadratic. And I've talked about this in some other videos, but you want to make sure, especially if you're doing a beam, that you pick the quadratic element. And there's something called shear locking that can occur if you use a linear element. And I'll talk about that when I do a video on elements. But essentially what that does is it makes the beam stiffer if you don't mesh it thoroughly or fine enough. So I'm going to right click on Insert Sizing. And then for geometry, I'm going to click the beam body. So I'm going to go up here and click, make sure I'm selecting bodies, and then click Apply. And then for our element size, I would like 10 elements. So I'm going to make the element size 0.2 inches. And then we'll right click, Generate Mesh. And we're going to set up our boundary conditions. So I'm going to go in here and I'm going to do the fixed support because this is a cantilever beam. So we're going to fix it at the left end. But instead of using this fixed support beam, I'm going to use something called remote displacement. So I'm going to click remote displacement and then I'm going to click the face that we want to constrain and click apply. Now you'll see here in the left, there's all these yellow boxes. So this will allow you to fix the displacement relative to a coordinate system for those nodes. So I'm gonna set all these to 0. So we'll have no displacement in the x direction, no displacement in the y direction, no displacement in the z, and then the rotation will be fixed as well in about x, y, and z axes. And I found that this gives a more accurate result to the hand calcs than using the fixed support. And the next thing we're going to do is we're going to insert and we're going to apply a force. So I'll click force, and then the way that I'm modeling it is I'm going to go up here and click edge and then apply it to the far right edge, click apply. And then I'm define it by vector components. And we want a 100-pound force in the negative y direction. So I'll put in negative 100. And now we're going to go and set up our post-processing. So what we want to look at, so for stress, I'll look at equivalent, maximum principal, and then from the hand calcs, you'll see that our bending moment and our normal stress is going to be in the x direction. So I'm going to go to stress, normal, and then make sure the orientation here is set to the x direction. And then we're going to look at the shear stress. And for the shear stress is going to be for this beam, it'll be in the XY, be the XY component. Now, the other thing that I like to do is I like to set up paths just to look at how the stress behaves through the part. So I'm going to right click on Model, Insert, Construction Geometry Path, and then I'm going to define this by nodes. So, and the largest normal stress is going to occur at where the beam is fixed. So I'm going to click on node selection here, and we know what the first point we want to look at this in the middle of the beam, so we got to go 5 elements in. Click on that node, click apply, and for the second node, we'll be at the bottom, and we'll set that to 0. Now I'm going to do one more path because I want to look at the shear stress through this part. Now, if you look at the shear stress at the fixed support, it won't quite match the hand calcs because there's some there's some strain going on when you pull on this bar, push down on it. It's going to pull away from the fixed support, and because of if you learned about Poisson's ratio, if you strain something in the axial direction, it'll be a strain in the transverse direction. So we won't quite see the most accurate strain compared to a hand calc. So I'm going to set up the next path again by nodes. Let's say we'll go here and go 5 in. Click apply. And then the second point we'll do on the bottom. So we'll go 5 in and click apply. Now I'm going to tweak, I missed the bottom node, so I'm going to do is modify this by hand. So change this to 4 inches and this to 0. And that looks pretty good. It looks like it's a little twisted. Oh, it did not stick the 4 inches. There we go. 4 inches. Okay, perfect. All right, and to post-process, we're going to look at the linearized stress. I'm going to right-click, insert, linearized stress. We're going to look at the normal stress at the fixed support. So that'll be path 1. And we'll look at the shear stress, linearized stress, shear, and it's the XY component. And there. Now we're going to right-click and hit solve. And it's solved. And there's our result. Now in the next video, I'm going to compare these results to some hand calcs and some theory. But yeah, thanks for watching, and hopefully you guys will stick around for the next video, and we'll compare these results to our hand calcs.